Good morning from Southern Illinois, Massac County, Illinois, Group 1 Illinois Wing. I'm Major Krempasky. I'm in Group 1 as an Aerospace Education Officer, and I welcome everyone to Illinois Wing's Aerospace Education Conference. I hope you learn a lot. I want to explain something before we start this video today for you. I am a retired science teacher, and I'm just trying to give you some ideas, if you're interested in astronomy, to find ways to get into this exciting and wonderful science. You know, when I think about the universe, I think about all the things that's going around and around in the universe and how it looks like those complicated mechanical clocks I used to see people working on when I was a kid. The universe is very, very exciting. We now have a much more enlarged space program. We've even got a space force. Let's not get into those details just yet. Let's just get into the sciences, so to speak. This presentation is about 32 minutes. I've turned off question and answers right now, but I'll turn it back on about 5 minutes from the end of the video. And I can't wait to hear from all of you. Have a great time. Victor, if you'll start the presentation, I would appreciate it, sir. Anyway, this is a general presentation just to give you some ideas, and I hope that you enjoy it. Good day from Group 1, Illinois Wing. Major Krempasky here. I am going to present to you some approaches to astronomy and hope that we can make this available to more of our CAP members. As a 5th grade student in 1960, I was exposed to the earliest efforts to reach into space with satellites and the first explorers. My teacher posted a diagram of the planets in our classroom with some basic information. Would you believe that the poster stated the following information? Jupiter had 12 moons. Saturn was the only planet with rings. The moon of the Earth had one picture, the one side that faces the Earth. These three items are now superseded with advances in space travel and technology. Some items have not changed, but are definitely more accurately portrayed. The Earth is approximately 93 million miles from the Sun. Venus has clouds, and with satellites we have more knowledge about the composition of those clouds. And I hope you like this general approach to astronomy. The science knowledge I had as a 10-year-old began with the foundation of the scientists and academicians of those days, including methods that are still a basic function for gathering information today. Isaac Newton's statement was true then, and as astronomy advances today, there are more shoulders to stand on in this year 2020. The three space pioneers are an excellent example of explorers who were willing to extend our knowledge by training and executing the first space missions. Missions which were designed to test the ability of our bodies to endure the energies and stresses of traveling into space orbit and then returning back into the atmosphere to the surface of the Earth. However, these pioneers do not accomplish their missions alone. The key word, teamwork. The team includes this list and more who contributed to the study, test, restudy, and learn about the problems encountered for safe space exploration, with safe meaning reducing all risk to a minimum. Placing early space explorers in orbit could not be accomplished without teams studying the problems and solving those problems as encountered. Once missions began to extend into days and weeks, space explorers wanted hot food. That was a problem. The solution was the invention of the microwave oven that is now sitting in our kitchens. Our aerospace education program needs teamwork on two levels. Our space program can only continue successfully If organizations like the Civil Air Patrol can provide members, especially cadets, with information that will stimulate their interest, growth, and development to advance talents and skills to progress with time. Secondly, for the Civil Air Patrol to provide education and information for our members, we need a broad team of aerospace educators who, as a single member, have limits, but as a team can reach out to each other to share knowledge between units, groups, and wings. For example, I majored in biology, and as a teacher, I have a general range of knowledge of sciences. However, I have little knowledge of physics, so when I have a cadet who's interested or needs help with physics, I need to find an AEO or another person who has the knowledge that I do not have. Teamwork is a big priority for CAP. Recruiting qualified members to serve as aerospace educators should be a priority for each unit, group, and wing. Sometimes encounters with those talented people occur when you least expect it. A few years ago, I was sitting in a barber shop when I overheard a man talking about building RC planes from foam. His casual talk inspired me to introduce myself. After an invitation for a demonstration at a CAP meeting, we had a new member for our aerospace education team. Now, when I use that phrase, my team, I'm not selfish, but it refers to the fact that I have added names to my AE notebook and am comfortable with asking them to help whenever needed. Those references are also available to other units, and I'm willing to share them with requests from those units. If someone in another unit is interested in my Parrot Disco or another drone, I am prepared to arrange a time, a place to share the drone with them, including a visit to my personal RC flying field on my farm. And remember, to promote all AE activities with regards to safety and the cadet protection policy. Robotics is another field that is extending our knowledge of the solar system and the universe. And it is a major limitation for me. I have very little knowledge about how these things are designed and work. But I have knowledge of a friend locally who builds robotic machines and solves technology problems. And while he's unable to join CAP as a regular member, he can, from time to time, upon request, assist us with some of our STEM activities. Two of the most interesting robots are on the surface of Mars. While originally scientists thought they would work for a few months, they have lasted for years. And scientists are looking to design more robots to explore our planets and the moons. A big problem is light. It is hard to make real-time observations in the presence of light pollution. So another important resource is to make a list of places where telescopes and binoculars can be used for astronomy activities. I live in rural Massac County, Illinois, and while it is not perfect, with proper atmospheric conditions, it's still a great place to do basic observations. While I may have a good place for observations, another type of person that would enhance astronomy is a hobbyist with telescopes and photography. Again, I have personal limits for this area of astronomy. Astronomy clubs and local post-secondary institutions might have a person or two who can make presentations and demonstrations of telescopes and cameras for our CAP members. One type of demonstration might include close objects like the moon, Mars, or Venus. With the correct telescope, a CAP class can learn so much by watching how that telescope has a basic setup and some of its adjustments to make it more effective. Other objects such as Saturn and Jupiter were visible during the summer and fall of 2020. Stronger telescopes are needed to see the moons of those planets and rings. But even without a telescope, it was fun just to watch their movements and positions in the sky at night. Mars is visible in the sky directly east from my location this November 2020. And remember, even binoculars can be effective for studying the planets nearby, but distant planets may need stronger telescopes. Events for the use of telescopes have many sources, such as the basic year's almanac, or an announcement by a local club, or an astronomy magazine. NASA also has a website which will provide information about activities and missions. It is not just the responsibility of aerospace education officers to have such information, but it's truly more effective if members who have the interest develop sources for themselves and share the information at CAP meetings. For spectacular images, aerospace education officers should also look for talented people with digital and camera photography, including knowledge and skills interested in selecting and maintaining photographic equipment. Not only basic knowledge of the lenses and focusing is necessary, but also understanding how the Earth rotates and revolves enhances the quality of images collected from our universe. I am emphasizing the need to have sources of talented individuals in and out of our organization who can teach these principles to our members. I have a subscription for this magazine. Every month, the information is current, and some of the articles extend interesting ideas and information acquired from various sources in the world. This is the information that I look forward to every month. Celestial maps are presented to help you locate objects with pictures indicating planet positions. The issues will present material 1 month before it occurs. For October skies, read the September issue and then make preparations. Here are 3 reasons I renew my subscription. This periodical often monitors the issues and points to discoveries from very qualified astronomers. Outstanding photography of solar and deep space objects. And lots of ads and support articles for astronomy equipment. Here are 2 other magazines that have been recommended to me. And I suggest before you select any subscription, go to a bookstore that has these magazines and study them for a month or 2. Go in and read about them, maybe purchase a couple of them, I guess you should. But examine them at the local bookstore and then make your decision on how you're going to stay current with events. At this point, one of the most powerful tools for exploring the universe is the Hubble telescope. Imagine all the information that is collected by this object. Images from this tool are found in so many places, including NASA sources, astronomy periodicals, the internet, and references in scientific journals. Of course, my favorite site on the internet is APOD, Astronomy Pictures of the Day. you will find images of Hubble and other images from various telescopes in our world. There are many apps, and most of my work is with iPhones and iPads with this app, Sky Guide. I have an iPhone 11 Pro, iPad 2, and 2 iPad 4s. And this app works flawlessly with all 4 items. When the app loads up, it'll point to the northern horizon of the sky around you. There is a setup for longitude and latitude so that you have the accurate picture of the sky near you. If you point to an object on the screen in Star Guide, the program will present an outline and information about the object's distance and brightness in the sky. Planets will also be placed in the sky map, and announcements concerning events such as meteor showers and comets are available. NASA has an app that you can download from your website, and it is available for all of the platforms that you see below, and for so many items that work in those platforms. Many apps are available besides just this first app by NASA. This group of apps are entitled Station and Shuttle, which are apps that present information concerning traveling in Earth orbit. Please note that humans are creatures that live normally with gravity, and space travel is usually without gravity, so much of the interest of Earth orbit missions is to study how space travel affects the physiology and physical effects upon the body. All of these apps are available to help us understand space travel. This group of apps are concerned with studies involving objects and concepts that are part of our solar system. Some of these apps use our solar system robots and provide information per those missions. Cassini and Rover are so important to obtaining information for astronomers to consider and understanding exploring our solar system. And the last app is very interesting to me. I was once told that tracking space junk is important to the safety of low orbit missions. Objects as small as a basketball are tracked. Wow, Space Junk Sammy is certainly one source for study of space junk. For deep space objects, such as stars, nebula, and galaxies of the universe, these applications are listed and recommended by NASA. Again, many platforms and devices are listed, and astronomers can gain knowledge with these applications. Perhaps one of the most interesting apps is the one entitled Space Weather. Amateur radio operators will tell you that solar wind and sunbursts affect communications on the Earth, hence space weather. And while we are creatures of sight, X-rays and radio energies are on the electromagnetic spectrum and are used to provide information about objects in our universe. The last group of apps recommended from NASA focuses upon the Earth and photography around the Earth. Some of these apps produce images with outstanding properties of simple beauty of the Earth and how it functions with many, many things in our universe around us. Again, Please notice that the platforms and devices that can be used with these applications. Let's take time and look at some of the objects in our solar system and the universe. What creates Saturn's colors? This picture of Saturn only slightly exaggerates what a human would see if hovering close to the giant ringed planet. This image was taken in 2005 by the robot Cassini that orbited Saturn from 2004 and 2017. Here, Saturn's rings appear directly over a curved line appearing brown, in part, from its infrared glow. The rings best show their complex structure in the dark shadows above that are created on the upper part of the planet. Here's an earthbound telescope picture. Still bright in the evening skies. This picture was taken when Mars was just past opposition, or its closest point to Earth, on July 31st. At that time, it was only 57.6 million kilometers away. This image, captured a week later, shows remarkable details of the planet, including its two polar caps. Despite its being close to Earth, it still appeared to be 1/74th the diameter of our moon. Photography at its best. Comet Hale-Bopp, the great comet of 1997, was quite a sight. This picture was taken on April 6, 1997, when the comet was imaged from a campground in California. To get this image the way it was, the photographer shined a light for 6 minutes on the rocks in the front of the comet, and then continued with its time exposure for several minutes afterwards. It has an impressive blue ion tail with sunlight reflecting the white dust tail of the comet. One of the bright spiral galaxies visible in the north sky of M63, the Sunflower Galaxy. It can be found with a small telescope pointed toward the constellation of hunting dogs, Canis Venatici. However, this picture from the Hubble Space Telescope exhibits the center of M63, complete with long, winding spiral arms glowing blue from a few bright young stars. There's a nebula glowing red from hot ionized hydrogen gas, and dark dust and numerous filaments. M63 interacts gravitationally with M51, the Whirlpool Galaxy, and several other smaller galaxies nearby. Light takes about 35 million years to reach us from M63. Now, what was going on in this Earth 35 million years ago? And if you were to try to travel the diameter of this particular galaxy, it would take 60,000 years at the speed of light. When I first saw this image, I thought immediately of a spider. About 7,000 light years distance in the southern sky of our Earth, This glowing hourglass shape was produced by a remarkable binary star system at its center. The nebulous duo of a white dwarf star with a red giant star shedding outer layers of particles which fall onto the white star. Outbursts from the white dwarf cause an outflow of gases delivered on both above and below the disk, resulting in the hourglass shape that you see. The bright central shape is about 1/2 light year across. This is the Southern Crab Nebula and was pictured in April of 2019 from Hubble. Can stars, like caterpillars, transform themselves into butterflies? No. But in case of the Butterfly Nebula, it sure looks like it. Its wingspan covers over 3 light years, and the temperature of its gases are estimated to exceed 200,000 degrees Celsius. It has a dying central star, and the featured planetary nebula has become exceptionally hot and bright and is visible in ultraviolet light, but hidden from direct view by a big cloud of dust. This sharp close-up was recorded by the Hubble Space Telescope and was reprocessed here to show off the remarkable detail of the complex nebula, highlighting in particular light emitted by iron, and it is shown in red. The Curiosity rover found that ancient Mars had the right chemistry to support living microbes. Curiosity found sulfur, nitrogen, oxygen, phosphorus, and carbon, key ingredients necessary for life, in the powder sample drilled from the sheepbed, mudstone, in Yellowknife Bay. The sample also revealed clay materials, and not too much salt, which suggests fresh, possibly drinking water once flowed at this site. Here's what a site looks like when it's drilled. Organic molecules are the building blocks of life, and they were discovered on Mars near the surrounding plains. The findings does not mean that there was life present or past on Mars, but it shows that raw ingredients existed for life to get started there at one time. It also means that ancient organic materials can be preserved for us to recognize and study wherever found in our universe. A picture is worth 1,000 words. Look at this. It is not really one picture. It is the work that combines hundreds of pictures that were laced together to produce a panoramic portrait of a site on Mars. This is really just beautiful. Coming up. Here is a future robot. Just months away from its mission. The headlines state, Mars is getting a new robotic meteorologist, Perseverance, and this is what the robot looks like. Once NASA's Perseverance rover touches down on February 18th, 2021, just 3 months from now, it will scour a crater for signs of ancient microbial life, and Perseverance will be the first robot that will collect planetary samples and then return them to Earth as part of this mission. The rover will also provide key atmospheric data that will help enable future astronauts to the red planet to survive in a world with no breathable oxygen, freezing temperatures, planet-wide dust storms, and intense radiation from the sun. Before I close this presentation, I thought it would be worthwhile to point out a few other places or sources for information. I particularly enjoy the Discovery Channel and the channel on our DirecTV for NASA. You can also look for information with some documentaries on Netscape and the History Channel. For the longest time, Nova was one of the best places to go to get information on the space travel. And then I found other places like Astronomy News and Science News. These are great periodicals for the science of astronomy. And last but not least, Astronomy for Kids. Remember, I started getting involved with space in 1958 when I remember my parents taking me outside so we could look for Sputnik. And somehow that really impressed me. And another time in around 1961, we got a phone call from my father who was working a night shift, and I got to see my first eclipse of the moon. Such things are what we need to light up the imagination of our young people for astronomy. I hope this presentation inspires many of you and our cadets to look at pathways to explore our universe, or even look to study various sciences. Perhaps some of our cadets will look for colleges and universities to become astronomers or to become part of the new space programs. And remember, let's keep adding to our aerospace education officer team. Thank you for attending this presentation. I hope you will remember to be safe first. Have a great day. This is Major Krempasky signing out from Group 1, Illinois Wing. Well, good morning, everyone. This is Major Krempasky. I've turned the question and answer session on if anyone has any questions. And I hope you've enjoyed that brief presentation. I worked on that for several weeks, and I could find a few errors here and there, but folks, I just can't tell you how enthusiastic I am about the study of astronomy. I have a front deck here on a farm here in Southern Illinois, and I enjoy it immensely, just sitting out there at nights with my FCC. That's my faithful canine companion. And it's just a wonderful time to just ponder the universe. And I use Sky Guide like I mentioned in the presentation. A few other notes here that I'd like to pass on to you before we close this session. Number one, there's a lot of interest in the stars, individual stars, how they begin, how they end. And there are star diagrams according to what color light they put out and the temperature of the surface of the star and how long they live and things of this sort. I always enjoy having the advantage of looking at some of those diagrams. And the second thing is to, constantly just go out and look up. I have a note here from Lieutenant Colonel Hiles, group of the 205 Squadron here in Illinois. We have a confluence of Jupiter and Saturn coming up on December 21st, and this will be the greatest conjunction in the next 60 years, and don't miss it. Well, thank you very much, Colonel Hiles, for that point out. Anyway, flash me a question. If you have them, we'll try to answer it. But let me tell you, we need more aerospace education officers to get in there and help teach these young cadets about what is out there for our great future. And I don't want to belittle any point, but everyone's got talents of various sources within aerospace education. And sometimes you never know, just like I pointed out, going out and looking for Sputnik, or going out. I remember we had a camp out at the Garden of Gods in Southern Illinois back around 1999. And kids from Peoria came down and for the camp out because we were doing land navigation with early GPS systems back then. And they never had seen the stars. Look at those stars. Are those stars? Many of our cadets live in urban areas where they just don't have the opportunity to see the stars. I have a question here from a Second Lieutenant Mark Stroyce. I hope I've stated that properly. Do you recommend a good first telescope for learning astronomy? Is it worth to get auto tracking? And I'm a little bit ambivalent. I think maybe for the younger cadets, a simple telescope without the extra add-ons, just to see if they're interested. I'm a trumpet player, and from time to time, parent will say, well, should I buy an expensive trumpet? Should I buy this or that? And I tell them, get a good used cornet. Sometimes I loan them one of mine or one of my trumpets or something, and see if the student is interested. And there'll be a natural inclination once they sort of get hooked into this thing that they might need a more advanced telescope. Now, remember, I'm not an expert on the telescope, but when I need an expert, I go to an astronomy club or my local college. We have an astronomer there who I refer them to for the telescopes. But the auto tracking that this young person or this person is mentioning is really a telescope that is capable of absorbing and counterbalancing the movements of the Earth. If you were to go out and point your telescope at Saturn right now and get it square in the center of the field, the Earth is moving. And as it rotates and revolves around the sun, it doesn't take long before that object is going to be out of that field again because of the great distances that are involved. So I hereby, recommend that you start with the simple telescope first, and maybe refer to someone in an astronomy club near you or someone in a local college to help you select that first telescope, and then encourage them to go to seminars or go to planetariums. Those are the best places for that kind of thing. Do we have any other questions, please? Okay. When I first saw that telescope built years ago, I couldn't believe that you could listen into the sky and learn anything from it. Once I got into college and started learning about frequencies and stuff, plus being an amateur radio operator, I learned that the telescope enabled, the radio telescopes enabled us to get information that we couldn't see. It sort of like reminds me of the first time I encountered a blind student at college, and they had to learn how to navigate things by counting steps and touch and or hearing sounds around them and things of this sort. And they had a way of gaining information that when the lights went out, I was in trouble. So anyway, I think the loss of that particular radio telescope, it'll take quite a bit of money to replace it. And I dread that no one will find the money to replace that huge and wonderful device. Okay. One final thing, if you ever need a place to look at the stars, I've got a 55-acre farm, and because of social distancing, I just enjoy it, and I'm willing to share it. I fly drones out here. I use the space out here to study how the wind affects the tracking of such devices. I got a beautiful place, and I love sharing it. Any other questions, please? Okay. Okay, yes, the solar flares that were mentioned, the space weather and stuff. As an HF communicator from time to time, those bands in the HF range seem to be more susceptible to winds, solar wind, and storms from the sun, but it can also affect VHF and UHF radios. Are there any other questions, please? Well, if not, I hope you've enjoyed the session. I've enjoyed being here, and I cordially invite you to any activity here in the Illinois wing that's appropriate, encampments, Johnson Flight Academy. We have so many wonderful things in the Illinois wing. It's a great team, and I'm appreciative of all the work that people put into it, including the producer of this video, who's in the background right now, Victor. And I'm going to ask him to close out the program, and please email me anytime. Krempasky at illinoiswing.gov. .cap.gov. illinoiswing.cap.gov. Thank you very much for your attention.